Hi all, welcome to today's session. So in today we'll be dealing with Jacobi's iterative method, and in this method we'll be given with a system of linear equations Ax equal to b, and this A will be a coefficient matrix, x will be the unknown vector and b will be the constant vector. So in this Jacobi's method we solve the values of this x by repeated approximation. So we'll just see what's the procedure for that. Suppose you're given with a system of equations a11 x1 plus a12 x2 plus etc a1n xn equal to b1. And similarly a21 x1 plus a22 x2 plus etc a2n xn equal to b2. Then the Jacobi's iteration, to get the iteration in the first equation we'll just keep this x1 in this a11 x1 in this side, and we'll just take all the other terms to the RHS, and then we'll divide this with a11. So you'll be able to separate x1, is it? And from the second equation what you do is you'll just keep a22 x2 here, and we'll take all other terms to the RHS, so you and divide it with a22, so you'll be able to separate x2. In similar way you will be able to separate x1 x2 x3 etc, and we'll just see how to get the next we'll just see from the problem. And we have a condition: this Jacobi's method will converge or will get a solution only if the matrix is strictly diagonally dominant. So what do you mean by diagonally dominant? The element, if suppose you are given first equation, then the first coefficient should be, its modulus should be greater than the coefficient of the other terms. Okay. For the second equation, the second coefficient should be greater. We'll just see in the problem and it will be clear to you. Okay. Now suppose you are given with a question. You are asked to solve the system of equation using the Jacobi iterative method, and you are given the solution. You are given the system. And first you need to check whether the system is convergent. Okay, whether the Jacobi's method for the converges for the given system. For that what you do is, here you choose 10, choose the modulus of 10, and see whether it's greater than the other two coefficients sum, which is 1 modulus of 1 plus modulus of 1, which is 1 plus 1 is 2. It's strictly greater than 10. So first row it satisfies, and for the second row just do 2 plus 1. We'll take this 10. Okay, and so 10 is greater than 2 plus 1, and for the third time we take this coefficient. Okay, we'll just see whether this coefficient is greater than the sum of the other two coefficients, and it's true. So for the three equations satisfy, so the method will converge. Let's see the problem. Solve each equations for the diagonal variable. You are given with three equations, right? And now what you do is you will just separate for x. First you'll just keep 10x here and take the variables of y and z to be set to right. Okay, you had here 12 and you had here plus y, you'll take here, and it will be minus y, you have here plus z, so you'll take that to this. Okay, then you have 10x here, so you'll just divide by 10. Similarly from the second equation, separate y. Okay, you had the equation 2x plus y plus z is equal to 13. So what you do is 2x plus 10y plus z is equal to 13. So you kept here 13, you just took minus 2x here, you took minus z to here, and just divided by the coefficient of 10. Separate from the second equation, you had three equation, and this is from the first equation, and this is from the second equation, this is from the third equation. This is the only step to remember in Jacobi's iterative method. And if you separate x, y and z, now you will have the initial approximation. So for the initial approximation you choose the values of x0 to be 0, y0 to be 0, z0 to be 0. Okay, then to get x1 what you do is you will just substitute y0 and z0 here. Okay, which is 0 0, so it will be 12 by 10, which is 1.2, and you will substitute here 0 0, so that would be 13 by 10, which is 1 by 3. Here also 0 0, so your z1 will be 1.4. Let's see. So x1, for x1 you will just substitute the values of y and z, which is 0. The 0 is called as the initial approximation. Okay, you have 1.1, 1.3, 1.4. Now you have your x1, your y1, your z1. Now you will get x2. How will you get the x2? For the x2 you had the equation 1 by 10 into 12 minus, you had x minus y, is it? So here to get x2 you do this y will be your y1 and your z will be your z1. Okay, the value you get from the previous iteration, and you just do and you'll just get an approximate value of 0.93. And now to get y2, what you do, you will choose the value of y, sorry, this is x2 from here 1.2, and your z will be from the values you substitute for x, y, z will be from the previous iteration. Okay, just do, you'll get the value, and similarly find z2. Okay, now to do z3, so to get x3, what you will do, you will do 1 by 10 into 12 minus, here you have the x value, sorry, here you have the y value, so that you will take for y, for x3 you will substitute 0.92. See, for x3 here you have 0.93 or 92. Okay, and from the previous z value, in similar way calculate x3, and you do y3 similarly from this is your x2. Okay, and this is your z2. To get y3 you will apply all values from the second iteration, and here also for z3 you just apply the values from the previous iteration, and then you have the value. And now see, you will see how you got the x4. You have 1 by 10 into 12 minus, you had here y, so your y will be y3, this is 1.024, minus you had z, so your z will be from z3, which is 1.03. Just calculate this and you have the value here. And similarly for y4 you have 1 by 10 into 3 minus, it was 2 into x, so that x will be your x3, minus you had z, so that z will be your z3. Okay, you just substitute the value for if you need y4, and if you have the formula x, you substitute the value of x3. If you have z, you substitute the value of z3. Okay, just we substitute the values from the previous iteration. And similarly we'll just continue, we'll just do for x5, y5 and z5 all. So you will have the value to be approximately equal to 1.002, 1.00, 1.00. So your values are approximately equal to, just do up to fifth iteration if it's not mentioned. Usually in problems you will be given how many iteration you need to do. So if not given, you just do up to the fifth iteration and just keep the value. So here x is also approximately equal to 1.00, y is equal to 1.00, and z is also equal to 1.00. So this will be a solution. Okay, now we'll just see another problem. Yeah, here the question is different. So you are given with a line and you are given with the data, and you will have to using the least square method and solve the resulting normal equation by the Jacobi iterative method. So first we need to form the normal equation. We know the normal equation of a line. How to form the normal equation of a line? We had summation y is equal to na plus b summation xi, and also we had summation xi yi equal to a summation xi b summation xi square. We'll just form the two normal equation, and then we'll form the necessary, we'll have the two equation and we'll solve for that. Okay, so for that also in the question it's given, we need to take the initial approximation as a0 is equal to 0, b0 is equal to 0, and we'll have to need perform 3 Jacobi iteration. Okay, so first you have x value, you have y value, you have xy value, you have x square value. Okay, and then what you do, you will just take the summation. Summation xi is 6, summation yi is 9, summation xy is 18, and here it's 14. Now to substituting in the normal equations, your equations was this one, summation y equal to na plus b into summation x. On substituting you have 9 is equal to 4a plus 6b, and here also on substituting you have 18 is equal to 6a plus 14b. Okay, and now from the, you had two equation. From the first equation you just, your variables are not x y, here your variables are a and b. So from the first equation separate for a will be equal to 9 minus 6b minus 4. From the second equation separate b will be equal to 18 minus 6a by 14. So you have the two equation. Now what you do, now you can just find a1 using a0. A0 is 60. You'll have to substitute the value of 0, so you have a1, and for to get b1 you substitute the value of a to be 0, and you have a1 and b1. And now to get a2 and b2 you use a1 and b1. Okay, to get a2, your a2 will be 9 minus 6 b1 by 4. Your a2 will be 9 minus 6 b1 by 4, which is 9 minus 6 1.2857 by 4. Okay, see, on doing, you will have this value, and your b2 will be 18 minus 6. Here it's a1 by 4. Okay, so your a1 is this, and on substituting you have 0.3214. And similarly, you are asked to do 3 iterations. Okay, do the third iteration also, and you have the value of your a is equal to 1.7679, and you have your b equal to 1.148. Okay, so what you do, you had the curve y is equal to ax plus b, and your a is approximated as 1.7679, and your b is this one. So y is equal to ax plus b, so it will be y is equal to 1.768 plus b is 1.148. This is approximated as 1.78. Okay, so it's okay. So this is the way you do the Jacobi's iteration. So we'll just do one more problem. Okay, you were asked to fit the parabola. Okay, so for fitting the parabola, you will have to form three equations, three normal equations, and we know how to do that. And you are given the initial approximation to be a0 equal to 0, b0 equal to 0, and you are asked to find the Jacobi's three iterations. Okay, so as you know, first we'll form the normal equation. So to get the normal equations, you need the values of summation x square, x square, x cube, x square, x cube, x raised to 4, y, x square, y. So just create all these tables. Okay, and then just get the values and then sum them, and you will get your n is equal to 4. 4 values are given, 4 data are given, and then on summing you will have the corresponding values. Summation x is 6, summation x square is 14, and similarly find all the values. Okay, and substitute in this equation, and you will have three equations. 18 is equal to this one, and you have this equation, and from the first equation you will separate a. Just keep 4a here, take 6b to here, 14c to here, and then divide by 4. You have your a. And similarly take your 14b, keep it here, just take minus 6c minus 36c divided by 14. You have b here, and from the third equation separate c. Okay, so your a b c, you have your a b c, and your first approximations are given to be equal to 0. So just find the values of a1, so that will be 4.5. By substituting 0 0, your b1 will be 0 0. Substituting 0 0, you'll have 3. C also similarly find it. Okay, now get your a2. A2 is like we obtain a2 using the b1 and c1. You obtain b2 by substituting a1 and c1. Similarly do the problem. Okay, and do the second iteration, and similarly the third iteration. And from the third iteration you have your parabola was equal to y is equal to a plus bx plus cx square. Your a is approximated as 8.75, and your b is 6.429, and your c is 2.29. So your parabola will be 8.75 plus 6.429x plus 2.299x square. So this is the way you do the problem. Okay, so hope you understood the session. Thank you.